Oh, sanibona guys, I hope niyaphila. Yeah. Njengoba bengithembisile ukuthi yabo ngizokwenza into right. Njengamanje sizoqala yabo i-strength 101. Yeah, topic 1 ngizoyiqala phansi. Yabo since abanye bebangekho. Yabo. So, our topic yokuqala nje ku-strength it's stress and strain. The easiest topic ever. Nawe nje ongakhona ukuthi uyicoshele kuyo kuphi ama-marks yabo. Okay, ke ngachaza ke mina yabo, if I can explain again to remind you ukuthi what is a stress. A stress, it's a force per unit area. Lona it's a force per unit area. Ama SI unit yakhona it's Newton per meter squared or pascals, right? This is what it's stress, right? Force per unit area. Then you got in a strain. A strain, what is a strain? Strain is a change in length per unit length, and we have in the sign for strain, it's OE or anje yabo. It's a change in L per unit length. Yona ke I dimensionless or injani unitless. You remember it's meter over meter and they cancel out. Then this thing strain has no unit. Ngiboneke wena bese ufama unit u strain singizoxabana nawo. Okay, what's that example? We got two types of stresses, right? We have a true stress, right, and a normal or a normal stress, right? But in our focus it will be normal stress, right? Because in normal stress it only focuses on the area affected by the load, right? Kuphela. A true stress is something else. You don't have to worry about it. Yabo, a story for another day. Yabo. Okay, what you have to know, right? People, strength is very easy. Yabo, we are dealing, right, with material. Ukuthi ama material angakhona kanjani na, or each material ikhona ukubamba how many load, right, per kilo yabo, into enjalo. That's what we are dealing with. Nothing interesting or expensive mhlampe yabo ongazi ukuthi inzima kanje. No, there is nothing. There is only that material, how material reacts due to some loads. Act kuphi, act kuyo, right? I hope ngizwile, right? Then you know from grade 8 or grade 2 there is only two types of forces. It's a push or pull. Even now stress, there is two type of stresses, tensile and compression, right? Type of stress of stresses, we have we have a tensile. It's a tensile stress and compression stress. How do we know compressive? You know, it's okay. How do you know what our stress is a tensile or compression, right? I told you last time that compression, it's whereby our length or our change in length will be decreased. Izoncipha, right? Whatever material our experience load izoncipha, meaning, right, minusa some length from the original length. But the tensile, we are stretching the material, meaning it's a positive sign, right? If my change in length it's positive, it means the force was tensile. If it's negative, it means the force was compression. All right, so far so good, hope so. Moving forward, we have what we call lentole, which is it's a ductility, right? Ductility, if I can tell you what is the ductility, it's something which tells you about the nature of the material. Kanjani na? Let me write this first. It's ductility. Ductility, right? This thing tells you about the nature of our material, right? Since we have many materials, right, because there are a lot of materials, right, in the world, but Tina Lana, we only deal with two, right? It's a ductile and brittle material, right? And I told you last time, if you can remember, we said the ductile material, it's what? It's a elastic material. It's the material that elongates more before it break, right? Then we have a brittle material. Brittle material, ngaze ngathi mina, it's suddenly, or it's a how material, suddenly or how. Athi ngizoyibamba kanjani into evesane yenzeni, ivesane iphuke nje esithubeni ungalindeli ukuthi iphuke, right? Those are two types of our material esizokwenzani, esizofocus kuwo, right? Then you have to know, right, how to differentiate these two, and how we're going to do that is based on the graph, right? But for now, I'll focus on the graph of the ductile material. Of ductile material, right? This is the most interesting graph ever, right? Which it compares the stress and strain graph, or it's called again the stress and strain graph. It is stress and strain graph. It's the same thing, right? Stress and strain graph. On your Y, you have what we call our stress. On this side, I have what I call my strain. Then we have this. This is a straight line here. Then we have something like this, right? On this graph, you only have 5 points which are very, 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 very important. Awo kyan kupa, kyan batla, kyan rappel ukuthi ningilalelisise kahle, right? These points are very, very, very important, right? If you don't know the use and the meaning of these points, then I don't see when uyobhala exam. Because why? Ngoba usuke ungazi lutho. Okay, asikho ke lapho sila. Right, we have this last point, this one which we call it a breaking point. It's a breaking point. It's a breaking point, this one. Then you have this, it's a ultimate tensile stress or strength, the same thing, but I will say stress. If you see strength, it's the same thing either, right? Then you have these 2 points, these ones are called, the upper one is called upper yield, then this one is called the lower yield. Ama yield am lawa O2. Then I have a point here before the upper yield, which is called this is my upper yield on it again, then this is my lower yield. Okay, at this point I have what? This is upper yield, this is lower, and it's shell. Breaking point ile. Then this one is my UTS or ultimate tensile stress, right? Then we have this point here, this one. This point is called the proportionality or the proportional limit. It's called the proportional limit. Okay, then from a proportionality limit point to a fracture point or a breaking point, we have what we call ilontuzana. It's a plasticity region. I will explain what is it. Plastic or plasticity. Plastic region. Then we have this range that is within from here to here, right? That is within the proportional limit, which is called elastic. It's called the elastic region. Bear in mind, have this point, right? Or understand. Manje, I will tell you in ama definitions akhona, then I explain everything after. So awuthi ngenze kanjalo. Okay, sithe sibanani, soqala ngane proportional limit point. My proportional limit point, let me underline here. The proportional limit. What is it? It is the certainly it is way the stress and strain are directly proportional. Right, it means if my stress increases by the factor of 2, also my strain have to increase by the factor of 2, right? Then we have what the second point, which is it's a upper yield. I'll say upper yield. It's a upper yield. Upper yield, it's whereby it is whereby my material, it is whereby the material starts to break, or you can say it is where, or it is where the material becomes easy. becomes easy. Yes. Then what else? We have a lower yield, right? A lower yield. What is a lower yield? A lower yield, it is where my strength remains constant, while it elongates. Right? Lower yield, it is where my strength remain constant, or it is where my load remain constant while the material elongates. Then we have the fourth point, which is a UTS, or ultimate tensile stress. I'll say UTS because you know the full meaning now. Lana, what is it? It is the maximum. It is the maximum load or stress a material can withstand before it breaks. Right? What is UTS? UTS yini ile load le imaterial ekhona ukuyibamba before iphuka, like is the maximum one, right? Let's say we create what? Let's say we have our table, and this is our table, and it's capable to hold in a 5 kilonewton load, right? Then what it means? It means the UTS, or the maximum load this table can hold, it's what? It's 5 kilonewton. Then it breaks, right? If when you apply 6 kilonewton on this table, the table won't take it. Why? Because it's over the UTS, or it's over the load esasiyenzela ukuthi ibambe. Hope you understand. So bear that in mind. It is the maximum load a material can withstand before its break. Basically, the last point is very obvious. It's a breaking point or a rupture point. There are many terminologies here. You have to know where are these points in the graph. This one is a breaking point, you know well. It is where material fails. Okay, yeah. Okay. These are my 5 points: proportional limit, upper yield, lower yield, UTS, and a breaking point. Then we have these important things that you have to pay attention on: the elastic region and the plasticity region. Astileni ngawo njengamanje sizoba nani? The elastic region. The elastic region here. Then we have a plastic or plasticity region. What is the difference? The difference is that when my material is still within an elastic region, when I remove a force, the material have to go back to its original position, right? Let's say you have this thing, this is my material. It's either I compress it or what. Let's say maybe let's say tensile with some force, right? At the end of the day, it elongates, then if I remove the force, it goes back to its original position. You can see the change in length there. It's what is equals to 0, right? Ibuyele ku original position yakhona after removing the force. I hope you understand. Ngizophinda ngithi mina elastic region it is whereby engizothi mina mangi-apply i-force kuphi na ku material yami, bese mase ngiqeda uyi-remove leyo force leyo, le material izobuyela back to original position, right? There is no change in length, right? That means leyo material yami is still on the elastic region, is still here, still on this region here, elastic region. Ayi-affecteki, yabo. But now we are, if you have something like this, let's say you have this to my material again, I apply a force here, then what happened after removing the force? Okay, yeah, elongator, but then after removing the force, ibuya la, right? You see now I have this gap here, which is my change in length. Uyabona ke la ukuthi kwenzakalani after removing the force, my material does not go back to its original position, right? La kade ikhona, meaning what, sekunani sengine change in length, isitensayilile, isistretchile le mpahla leyo. Kusho ukuthini? Isiyenqile kuphi? Ku proportional limit, right? Isekuphi? Isingale ku plastic region, right? Okay, what I want you to take note of ukuthi ku elastic region, our focus on the elastic region, you have to know this, ukuthi on or in the elastic region, right, we deal only within a Hooke's law. This one, it says it deals with the spring. If you apply a force on a spring, it shall go back to its original position. It tells you a stress and strain are directly proportional, right? It tells you stress and strain and strain zinjani directly proportional, meaning if you can see the definition of the Hooke's law is the same definition of what, of the proportional limit, right? Is the same thing, right? So we say it in ku elastic region we only apply in Hooke's law, right? Hooke's law ithini? Stress and strain, they are directly proportional. Ku high school the formula was saying this, okay, changing x. This was our Hooke's law from Eskoleni, right? Now manje we are still using the law but on a different format. Yabo manje my equation for that, what will say izothi yona it's E for ilontuzana young modulus, then izothi stress over strain, then nakhona SI unit athini, athi pascals, or if you ufuna ukuthi pascals you can say Newton per meter squared. Lawa ma SI unit lawo, it's either you write pascals or newtons per meter, right? Ithini into ithi wena on elastic region you only use the Hooke's law to get anything that you want. If they ask you find the Young modulus, right? Find the Young modulus. If they say find the Young modulus, right, it means you're going to use Hooke's law. Then another thing I'm gonna uyibambe just for understanding. You see this area. You see this area under this graph. This area here under this graph. This area under this graph represents Young modulus. Young modulus. Then what is Young modulus? Young modulus, it only tells you about how strong my material okay, material is strong kangakanani. Isingisa ngisazi ningixolele. Material yami is strong kangakanani, right? Why is it thina sikhona ukutshelwa yile line leli? It's only because the stress and strain, they are directly proportional. Once I'm beyond the proportional limit point, it means my stress and strain, they are not directly proportional. Why in conclude anjalo? It's because you know what ngitheni ku upper yield, ngithe mina ku upper yield, right? The material start to break. Buka ke lower yield ithini. It is where my strength remains constant while it elongates. You see, there are no proportional much. Ayisekho i-proportionality between in stress and strain. That's why singenzeni singakhona ukudetermine i-Young modulus of the material using the information beyond in a proportional limit point, right? Hope you understand. Okay, right. This is what Young modulus. This is my Young modulus. I have to keep it in mind. Okay. Another thing that you have to know, let me see, is this important equation. You will use it so much. You will use it so much, this equation. If ungayazi, just don't go and write the exam. It's change in length equals to, it's P or a force. Let me just say a force just for the sake of you. But it's force, then the length, then its area, then it's my E, which is the Young modulus. This is the thing, right? Oh, if you don't want to write it this way, you see what force per unit area, what is it? It's a stress. I can say this formula is equivalent to stress length over Young modulus. Yabona equation le ifaka othandweni. This equation, you have to use it, like it or not. Uyithande nje, ukuthanda ezinye izinto. Okay, asikho ke lapho. Yonke lento le isibeka to our next subtopic of stress and strain, which is the percentage. Percentages, right? Because you know nisazohamba niyokwenza ini lapha lab niyokwenza ama experiment, right? Ukwenza ama tensiling and stuff, yonke leyo nto leyo. So you have to know that if my material elongates such as this, if my material elongates, there is a percentage of elongation, and if air compressor, there is a percentage of a reduction, right? So I'll say now percentages ekumele uwazi how to calculate the percentages. If material yami, my material undergo a tensile, let's say a tensile and tensile stress or force. So weaknessa ini sizoba nani nelontuzana elongation. It's a elongation. There is a percentage of elongation. Calculator kanjani yona? It's very simple. It has no it's a signature ukuthi mhlambe if signature khona ithi no, just say equals to, then you have what? You have your LF. LF is what? Is your final length minus the original length over original length times 100. You see? LF ngimthatha phi ke mina ngithi LF buka la angithi at this point nginobani, ngino LO, which is my original length from here to here. Then mase elongated this part right to here, ngizoba nobani, ngizoba no LF, which is my final elongation. Then ngenza lokho njengamanje, it's what? It's LF minus LO over LO times 100. Uthola elongation yakho, right? Bese if material yami undergoa ini, undergoa, let me write it. Okay, if my material undergo any a compressive or a pushing compressive stress, kuzoyenzakalani? Sizo experience ini reduction. It's a reduction. So experience a reduction in percentage reduction, right? Iti nike yona iti izoti, it's equals to izoti LO minus LF all over bani LO times 100. No, here it's LF, my mistake. Supposed to be LF because we don't take negative percentage. LF over LF times 100. Then that's my percentage. Then again we will have what we call any, if again my material undergoes any tensile stress. If my material undergoes any compression force, we will have a reduction in area, right? A reduction in area if my material ini i-tensile, siqala compression, compressive force. I will have ini reduction in area, but in terms of percentage reduction in area. Nakhona, what is the formula? The formula is obani AO, original area minus final area, over original area times 100. Right, then in elongation in area is the opposite of this thing. It's whereby it undergoes in tensile. Tensile yona izothini, izothi percentage elongation in area. Izothini yona, kumele ithi final area minus original area over final area multiplied by 100. Then I get what we call my percentage, right? So far so good. Yeah. Then for now, I will take you to what we call any factor of safety. Alright, factor of safety is something that we use often in the engineering industry. Factor of safety. Right, what is it? It is the factor that extend the safety of design. Right, is the factor that extend or make yenza show, but I'll say extend the safety of whatever we design. Safety of our design. That's why we have our buildings angawi. It's because the factor, right, is great. The factor it's supposed to be 1 actually. If it's 1, it is the perfect factor of safety because it shows what it's 100. My building or my design will stay whenever. Right. Okay, to get the factor of safety, what you are going to say, formula nje encane engathini, factor of safety uzothini, ithe UTS. Yakhumbula what is a UTS? Ultimate tensile stress or strength, up to you, over ini working. It's a working or allowable stress, or it's a allowable stress. I will tell you what is the allowable stress or a working stress. Right, a allowable stress, take note of this. My allowable stress, the meaning of allowable stress or working stress, allowable stress, allowable stress is the load that a material can hold without bypassing is the material that is the load that a material can hold without bypassing the elastic region. The elastic region. Meaning, allowable stress. Meaning EUTS will be always the ultimate tensile stress, and is the maximum load a material will stand, whilst the allowable stress, it is the load a material can hold without bypassing in elastic region. Meaning UTS will be always greater than the allowable stress or working stress. Allowable stress, right? Sibuyele nje emuva kancane. Uyakhumbula ukuthi ngithini? Sibuyele emuva kancane. Masibuyele emuva kancane sizoza la ku graph, right? Go back, masibuyele emuva ku graph, meaning our allowable stress sizoyithola kuphi na? Sizoyithola within this region, elastic region, somewhere there, right? Somewhere here, meaning it is the point before a proportional limit, right? Which will be our working stress. Okay, fine. Hope you understand the difference between the allowable stress and the UTS. So bafethu okwamanje, that's the thing you have to understand for now. This is our introduction. Our next topic will be under in stress and strain, but will be axially loaded members, right? Siyabonga.